Welcome. Today I take an important class regarding relation. Before, in the consecutive 3 class, I discussed in details set theory, De Morgan's law and their corresponding proofs, Venn diagrams, etc. So today I discuss about the relation. Before discussing relation, we have to know what is order pair. And one important thing is that up to set we discuss about the one dimensional data, that is only on single data. The elements are in single. Now today I discuss about the bivariate data, that is the element are taken as pairwise, that is called the order pair. So at first you have to know what is order pair. If we consider 2 elements A and B, then they are said to be order pair if they can be written as like A comma B. This is called order pair. Therefore, it is very clear that this looks like a point in the coordinate geometry system in 2 dimensions. Therefore, it has a definite position in the plane. Therefore, the order pair represents by A comma B within first bracket. Now, I discuss about Cartesian product. What is Cartesian product? Let us consider 2 sets A and B respectively. Then, A cross B is called the Cartesian products of the set A and B if its elements are pairwise, in which the first element is coming from the first set and second element is coming from the second set. Let us discuss in details. Let capital A be a set which contains element 1, 2, 3 respectively, and capital B be a set which contains elements small a and b respectively. Therefore, the cardinal number of the set A is equal to 3 and cardinal number of the set B is equal to 2. Therefore, Cartesian product A cross B is equal to 1 comma A, 1 comma B, 2 comma A, 2 comma B, 3 comma A and 3 comma B. Therefore, the elements of the Cartesian product A cross B are the order pair. You see it is very clearly on the board. But first element is coming from the first set, that is capital A, and second element is coming from the second set. Therefore, the total cardinal number of the Cartesian product A cross B is equal to n of A cross B, that is cardinal number of A cross B is equal to cardinal number of A into cardinal number of B. That is the rule. Therefore, 3 into 2 in this case, that is 6. Therefore, the cardinal number of A cross B is 6. Now count 1, 2, 3, 4, 5, 6. So there are 6 pairs. Now I discuss about the relation. Let us consider capital A and capital B are 2 sets. Then a relation define a set A from set B such that R is a subset of A cross B. Then R is called the relation. Again I repeat, if capital A and capital B, let us consider A is equal to a set which contains same example 1, 2, 3 and B is a set which contains 2 elements A and B. Then A cross B, that is Cartesian product of A and B, contains these 6 pairs 1 comma A, 1 comma B, 2 comma A, 2 comma B, 3 comma A and 3 comma B. Therefore, R, that is relation, is a subset of A cross B. That means the elements, that is the order pair, belongs in the relation R already contained by A cross B. And R rule. Relation is a rule in which we collect the ordered pair from A cross B. Now let us consider one example in this case. Let R is a relation. R is a relation. It contains the elements x, y such that x is less than 3 and greater than 1, comma, x belongs to capital A and y equal to small a and y belongs to capital B. That is the rule. Again I repeat, R, that is a relation, contains the ordered pair like x, y such that what is the value of x? X is less than 3 and greater than 1 and x belongs to the set A and y is equal to small a and y belongs to B. Therefore, according to this rule, R contains the pairs as 2, A, only 2, A. Right? Therefore, clearly 2, A belongs to A cross B. Therefore, R is a subset of A cross B. Hence, we can say that relation is a subset of A cross B. Now, relation on a set. If we consider set A, then a relation R defined on itself, that is defined on A cross A, then the relation R is called relation on a set. Therefore, in this case, R is a subset of A cross A. Therefore, in case of relation in a set, R is a subset of A cross A. Now I discuss another important thing, that is domain and range of a relation. Domain and range of a relation. Just a minute. Let capital A be a set, contains 1, 2, 3 and capital B be a set, contains AB, and let us consider R be a relation which contains the element as 1, A and 2, A. Then if we draw the diagram of the set A, then it contains 3 elements 1, 2, 3 and in case of B it contains the element A and B. Clear? Now if we draw the diagram according to the relation R, then 1 is related with A and 2 is related with B. Therefore, from the set A, only 2 elements 1 and 2 are involved in the relation. Therefore, domain of relation is equal to 1, 2 and range of relation is equal to A. That is the important point. That is the important point. What is domain of relation and range of relation? The elements of the set A which are related in relation, the set contained within that elements is called the domain of relation, and range of relation, the elements of the set B which is involved in the relation R is known as the range of the relation. Now I discuss about the different types of relation. Number 1, null or void relation or empty relation. Null or void or empty relation. Let us consider a relation R defined on the set A itself. Then we consider relation R in such a way that R does not contain any pair. R does not contain any pair. That is the rule of R does not satisfy any pair of A cross A. Then the relation R is called the null relation or empty relation or void relation, and it is denoted by phi. So phi is a subset of A cross A in this case. Therefore, it is called the null relation or void relation or empty relation. Then come to universal relation. Universal means we know that all things. Therefore, a relation R is said to be universal relation on a set itself. If R is a equal set of A cross B. R is an equal set with A cross A. Therefore, all elements of R and all elements of A cross A are same. Therefore, in this case, R is a subset of A cross A and A cross A is a subset of R. That is, R is equal to A cross A. In this case, R is called the universal relation. Then number 3, identity relation. If we consider a relation R such that it defined on the set A itself, that is R defined on the set Cartesian product A cross A, then R is said to be identity relation if R equal to x comma x such that x belongs to the set capital A. Let us consider capital A is equal to 1, 2, 3. Therefore, R equal to 1, 1, 2, 2 and 3, 3. This is called the identity relation. Here R is a clearly subset of A cross A. Again I repeat, what is identity relation? If we consider a set capital A respectively and it contains the elements 1, 2, 3 such that R is a relation which contains the order pair 1, 1, 2, 2 and 3, 3, then R is called the identity relation of the Cartesian product A cross A, that is R is a subset of A cross A. Clear? Now, next type is reflexive relation. Reflexive relation, let us consider a relation R on a set A itself such that R contains some element. If R is equal to x comma x such that x belongs to the set A, that is A comma A belongs to R implies A belongs to A. That is, if small a is an element of the set capital A, then A comma A belongs to R. If small b is an element of the set capital A, then B comma B is the element of R. Then it is called reflexive relation. So therefore we can say that reflexive relation is a kind of identity relation. But there is a very small difference. What? In case of identity relation, only identity elements are exist. No other elements are there. But in case of reflexive relation, identity element must exist as well as other element may exist. So that is the difference between identity element and reflexive element, relation. Next, symmetric relation. What is symmetric relation? Let A comma B belongs to the relation R, which implies B comma A belongs to R, such that A, B are the elements of the set capital A. So if A, B are the elements of the set capital A and A comma B is a pair which belongs to the relation, which implies B comma A belongs to the relation, it is called symmetric relation. Then number 3, reflexive, symmetric and now transitive relation. What is transitive relation? Let us consider 3 elements A, B, C which belongs to the set capital A respectively. Again I repeat, A, B, C are 3 elements which belongs to the capital A. Then if A comma B belongs to R and B comma C belongs to R, which holds, implies A comma C belongs to R, then we can say that R is a transitive relation. So if a relation R is symmetric, transitive and reflexive, then the relation is called equivalence relation or RST relation. Therefore, R is said to be RST relation or equivalence relation if R is reflexive, symmetric and transitive. Okay. So today up to this. In the next class I will discuss about anticipating relation and mapping of function. Okay, thank you.